Good morning, Algebra 2. During this video, you should fill out the Frayer model that's in your notes. So the Frayer model is the thing that looks like it has 4 boxes in it, a circle in the middle. You should be filling that out as we go along. So today we're going to talk about exponential functions. An exponential function is any function of the form y equals ab raised to the x power. So that's our definition. Now, this b is any constant number. So that b will always be a constant, and the x is always going to be a variable. So this kind of changes it up a little bit. Before we had things of the form y equals x squared or y equals 3x plus 2. Neither one of these are exponential because it doesn't have an exponent in the variable. There's no exponent, or there's no variable in the exponent. Sorry, there's no variable in the exponent. So neither one of those are exponential. Let's look at the graph of one of these functions. Here we have the function f of x equals 3 times 2 raised to the x power. This is exponential because I have an x in my variable. So the first thing I want to do is just kind of fill out a t-chart. So here I have x, y. I'm going to go from -2 to 2. Now, when I type this in the calculator, I get then that this is 3/4, 3/2, 3, 6, and 12. So the graph of this is going to be increasing. At 0 it's 3, at -1 it's 3/2, and then 3/4, and then at 1 it's going to go up to 6, and then up to 12. So notice that this graph increases steadily as it goes along. This is what is known as exponential growth. Because as x increases, f of x also increases. As my x's are getting bigger, my y's are also getting bigger. Now there's two types of growth, exponential things we talk about. We talk about growth and we talk about decay. So this one right here is exponential growth, because as x increases, your f of x also increases. This one is decay. It's called exponential decay, because as x increases, y decreases. Or you can kind of just think about the fact that it's getting smaller. So looking at this one, this is growth because as x gets bigger, y gets bigger. This one's decay because as x gets bigger, y gets smaller. If you notice, on both of these graphs, they have an asymptotic behavior here at the x-axis, meaning they get closer and closer to the x-axis, but they never touch it. So in simple exponential equations, you have an asymptote at the x-axis. Now remember, this is for simple exponentials like we're dealing with today. There may be more that look like that. Now, what I want you to do, I want you to look at growth factors and decay factors. There are 6 graphs that I want you to look at on the next page. On those 6 graphs, I want you to determine what makes a growth factor and what makes a decay factor. Okay? How can you determine the difference between growth and decay given the equation f of x equals ab to the x? Which one gives you a growth and which one gives you a decay? Go ahead and figure that out now.